Now let's see what happens when we add an extra forcing term. And you'll see, it'll be super, super cool. And in particular, let's consider the equation y double prime plus 4y equals 5 cosine of 3t with initial position 1 and initial velocity minus 4. And so what we have here, no damping because there's no y prime term, but we have a forcing term, namely f of t equals 5 cosine of 3t. And the analogy I like to use is like you swing on a swing and you use your feet to propel your motion. That is what a forcing term here is. And the question is, will this have an effect or not? Stick around, we will see. And as I mentioned before, I will not fully solve this problem. The details are in the lecture notes, but because more important to analyze this here. So because it's inhomogeneous, we have to find a homogeneous solution. So the auxiliary equation is r squared plus 4 equals 0, where r is plus or minus 2i, and that gives you the homogeneous solution, a cosine of 2t plus b sine of 2t. And then for the particular solution, So remember, we first need to check for resonance, which will be extremely important here, you will see. So the right-hand side is 5 cosine of 3t. Which root would give you 5 cosine of 3t? I think a cosine of 3t. It would be r is plus or minus 3i. And notice it does not coincide with the homogeneous root. So in this case, there is no resonance. Doesn't coincide. So literally, physically here, there's no resonance. And so, which tells you we just have to guess the usual thing. So we have 5 cosine of 3t. So a cosine of 3t plus b sine of 3t. And then if you plug it in, so if you plug into y double prime plus 4y equals 5 cosine of 3t, and you can check that in the notes, you will eventually find that a is minus 1 and b is 0, which gives you the particular solution minus cosine of 3t, and then the general solution y is y naught plus yp, which is, I think, a cosine of 2t plus b sine of 2t minus cosine of 3t. And last but not least, to solve for those constants, you use y of 0 equal 1, and y prime of 0 is minus 4, and you eventually get a equals 2 and b equals minus 2, which finally tells you that if you have this forcing term, then your solution is 2 cosine of 2t minus 2 sine of 2t minus cosine of 3t. Okay. So rectangle that I want it to be a I mean, it's a circle that I wanted to be a rectangle, but okay. Now let's see what this looks like in terms of a picture. So the question is, does the forcing term affect the motion? Well, here's the picture. Well, yes, but not too much. You see, the motion is still sinusoidal. So motion is still a more or less sinusoidal. Or less. Sinusoidal. It's like Zoidberg. Zoidal. Meaning that the forcing, of course, it has some effect because it's not a pure sine wave, but not much of an effect. So here, forcing has some effect, but not too much of an effect. An effect. And in fact, we can sort of label this a little bit, so we can call this by names. So just remark, first of all, the homogeneous solution in physics, that's sometimes called the steady state solution. So y is 2 cosine of 2t minus 2 sine of 2t. That is sometimes called the steady state solution. I'll show you a picture in a second. Solution, which is the solution without forcing. So if the forcing were 0, you would get this pure sine, sine and cosine wave. The particular solution, minus cosine of 3t, that is sometimes called the transient solution. Solution, and it's really the pure effect due to forcing. Due to forcing. In other words, what effect does the force have? The answer is minus cosine of 3t. So let me show you a picture of what this looks like. So in this case, the steady state solution was this big sine wave. The transient solution was this small sine wave. And what is our solution itself? It's just the sum of the two. So if you add those two sine waves, you get this. Let me add this down here. So in other words, if you add the red solution with the green solution, you do get the blue solution. Or in other words, y equals y0 plus yp says that the solution is the steady state solution plus the transient solution. So once again, in this case, the forcing term doesn't have much an effect because there is no resonance. And in the next video, the grand finale, we will see what happens when there is resonance. Da 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 da.